Hello friends, I welcome you all in this session. As you are aware, in previous session we discussed some basic concepts related to probability. We have seen what is experiment, what is event, what is joint probability, what is the use of Venn diagram and so on. We have seen what is mutually exclusive event, what is the meaning of collectively exhaustive list as well. In today's session, we are going to work out couple of exercises and we will see different types of probabilities. So, let us look at this question. You have to prepare a collectively exhaustive list of the possible outcomes of two dias. Just think for a while and try to answer this question. So, you are throwing two dias at the same time and you have to find out what are the possible outcomes. Okay. So, the possible outcome, let us say it would be on first dias and let us say this is second dias, right. So, first die, second die. So, the outputs are, let us say on first you are getting 1 and then on second also 1, then on first 1, on second 2 and so on, right. So, on first 1 and on second 6, is not it. Let us say 2 1 2 2 and so on, right, 2 6. So, finally, what you will have 6 6, is not it. So, you will have a list of 6 rows and 6 columns, wherein you would be writing down all possible outcomes. So, this is how you can prepare a complete table, right. So, 1 1 to 1 6, 6 1 to 6 6. Okay. Now, what is the probability for each of the following totals in the rolling of two dias? So, again you are rolling two dias simultaneously. Now, what is the possibility that the sum of the dots appearing on those two dias is 1? Is it possible to have sum of dots on those two dias equal to 1? You can't have a situation like this, is not it? So, this would be answer would be 0 by 36, is not it? What about 2? What would be the probability? So, you are getting 1 on first die and again 1 on second die, right. So, there is only one way in which you can obtain sum as 2, right. So, it is 1 by 36. What about 5? So, let us say you are getting 3 2 on first die 3 and 2 on second die, then 2 3, is not it. Is there any other possibility of getting sum as 5? 4 1 and 1 4, right. So, there are 4 ways, right. So, 4 by 36. What about 11? Is it possible? So, you can have 6 and 5, 5 and 6, right. So, it is 2 by 36. So, these are remaining answers, right. Now, let us look at different types of probabilities. Basically, there are 3 types of probabilities. The first one is classical probability or classical approach to the probability, then relative frequency approach, and the third one is subjective approach. We will see each one of these in detail. So, classical probability is also known as a priori probability, is the simplest of all these 3. So, the number of outcomes where the event occurs to the total possible outcomes. So, let us say if you toss a fair coin, so the possible outcomes are only 2, right, and the probability of heads is 1 by 2, right, or the probability of tails is again 1 by 2, is not it. Let us say if you throw a die, then what is the probability that 5 dots would appear on surface? So, it would be just 1 by 6, or P4, what it would be again 1 by 6, is not it. So, this is known as classical probability, the number of outcomes to the total number of possible outcomes. Now, we call this, as I said, a priori probability. Why we call it a priori probability? Because to get the answers you need not perform any experiment, is not it. You need not actually throw a coin to know what is the probability of getting heads, right. So, that is why this one is called a priori probability. So, let us look at some more examples. So, find the probability of selecting a face card from a standard deck of 52 cards. So, how many face cards are there? So, you have got 3 types of face cards, jack, queen and king, right. So, you will have 4 jacks, 4 queens and 4 kings, right. So, it is 12 by 52, is not it. So, this again you need not actually select a face card from deck of cards, you can just get the answer using that particular formula, right. So, this is 12 by 52, right, 3 by 13. Let us look at the second type of probability. This is relative frequency approach to the probability. Now, let me ask a question, what is the probability that you will live up to the age of 85 years or let us say 105 years, is not it, or let us say what is the probability if you let us say establish a plant near a river, and then what is the, how many fish would be killed from the pollutants which would be coming out from that plant. Can you find out that probability? Or let us say what is the probability that the speaker of the TV would blow off when you turn its volume to its full level. So, for knowing answers to all these questions, you need to perform some experiments, is not it, then only you can find out answers. So, this method uses relative frequencies, or you should have some past data. So, if you have got past data, you can predict future on the basis of past data. So, how often something has happened in past, we will predict future on the basis of that. So, relative frequency approach is based on past data, or you need to perform experiment. So, let us say if you are finding what is the probability of getting heads. So, if you toss a coin, you may get tails, is not it. Second time again you may get tails. But if you toss a fair coin, let us say for let us say 300 times or 1000 times, then over a period of time, after some time, the probability of heads would be, or probability of tails would be stable, and that would become 0.5. If you look at let us say first few 75 trials, this is 75, right. What is the probability here? It is near let us say 0.8, is not it. But as you increase number of trials, is not it, then this curve becomes stable, right. So, relative frequency becomes stable as number of tosses become large. But the limitation of this particular types of probability approach is that you need to perform sufficient number of experiments before getting answer. So, this is relative frequency approach to the probability. The third and the most important, because most of the people sitting at the top who are decision makers, either in business or in any other sector, or in government or army or whatever area you take, they are faced with unique situations most of the times, rather than facing a long series of identical situations. So, they use their experience, their knowledge, their wisdom to make necessary decisions. So, this type of probability is known as subjective probability. It is based on belief, experience and judgment. Let us look at couple of exercises Let us say there is a CEO in a company and there are several managers working under this fellow. So, these are different managers and there are several employees, right. Now, these managers have decided and they would come up with a retirement policy, and that policy is to be presented to CEO. But before presenting the policy to CEO, in fact, one of the managers decided to conduct a poll amongst machinists and inspectors working in that organization. So, he contacted 30 machinists and 30 inspectors. Out of 30, 9 of them strongly supported it and 4 of them strongly opposed. Similarly, for inspectors as well, right. Now, the question is, what is the probability that machinist randomly selected from the polled group mildly support the package? Mildly support the package. So, first of all, how many machinists were contacted? 30. So, 30, right, and mildly support, right, 11. So, 11 by 30 is the answer to this question, this part of the question. What is the probability that an inspector randomly selected from the polled group is undecided? Inspector and undecided is 2 by 30, is not it? What is the probability that a worker, either machinist or inspector, randomly selected from the polled group strongly or mildly support the package or the policy? Strongly or mildly. So, strongly and mildly and all the workers, right. So, this becomes 20 and this becomes 13, right. So, total is 33, 33 by 60, is not it, because we have to look at all the workers, right. What is the what probability estimates are this? These are relative frequency probability, right. Let us look at one more exercise. Now, classify the following probability estimates as to their type. So, these are different questions and we have to identify which statement is of which type of probability, right. So, let us look at this. The probability of scoring a penalty shot in ice hockey is 0.47. So, what kind of this probability is this? The probability of scoring on a penalty shot in ice hockey is 0.47. So, this is, you got this information from relative frequency approach. The probability that the current mayor will resign is 85%. This is subjective, right. The probability of rolling 2 sixes, the probability of rolling 2 sixes with 2 dice is 1 by 36. Would it be relative frequency or subjective? No, it is classical approach, right. The probability that a president elected in a year ending in 0 will die in office is 7 by 10. The probability that president elected in a year ending in 0 will die in office is 0.7. This again relative frequency approach, right. The probability that you will go to Europe this year is what? It is 14%, is again a subjective probability. Okay. Now, let us look at couple of probability rules, some addition rules. So, first of all, let us look at what is the probability of happening of an event is PA. This is how we denote it, right. So, either you call it marginal or unconditional probability. It is basically a probability of only one event, and this is called marginal or conditional or unconditional probability, right. So, let us say in your class there are 50 students. What is the probability that one of them is winning free tickets to National Rock Festival or any other festival for that matter? So, it would be just 1 by 50. So, P A would be just 1 by 50, is not it? Probability of one or more mutually exclusive events. So, what are mutually exclusive events? Those events wherein only if there are two, then only one will occur at a time, right. So, addition rule for mutually exclusive events. So, probability of either A or B happening is probability of A plus B. So, let us say there are 5 students, what is the probability of A is getting selected for placement is 1 by 5, A or B selected is just summation of these two, right, or A and D, A or D selected is again 0.4, right. So, this is 1 by 2 and 1 by 2 is 0.4. Let us look at this example. So, in a survey you have found that the proportion of in a city you have found that the proportion of having these many children is 0, right. So, 0, no child in a home, and the probability is 0.05. Probability that in a home there are 5 children is 0.10 and 6 or more is again 0.05. So, this information is given to you, you have collected this data from a survey. So, what is the probability of randomly chosen family having 4 or more children? So, 4 or more, it means all these probabilities you need to sum up. So, 0.15, 0.10, so this becomes 0.30, and we also know that P A and P A naught has to be equal to 1. Okay. So, let us say in this question we have asked our question is like this: what is the probability of randomly chosen family having 4 or more children? If I ask a question, what is the probability that the families have got up to 3 children, then what it would be? It is 1 minus 0.3, so 0.7, is not it? Let me delete all these. What is the probability of family having 5 or fewer children? So, we have to look at 5 or fewer, right, 5 or less than 5, right. So, just add all these probabilities, or since you know the probability of 6 or more, you just subtract 1 minus 0.05. So, you will get 0.95, is not it. So, this is how you can work out a question like this. Now, let us look at additional rule for those events which are not mutually exclusive. Earlier we have seen additional rule for events which were mutually exclusive. So, not mutually exclusive means what? Both the events can occur simultaneously, right. So, let us look at this example. What is the probability of drawing either an ace or a heart from a deck of cards? Ace and heart can occur together because we can have a situation wherein an ace is of heart as well. So, thus ace and heart are not mutually exclusive, they may happen together. So, let us look at this Venn diagram. So, probability of event A, probability of event B, and this is probability of A or B happening together. So, how to work out this example? So, probability of A or B is equal to P A plus P B minus P A B. So, this area is to be subtracted, otherwise there would be double counting of this area, is not it. So, probability of ace or heart is what? So, you got 4 number of aces are 4, right. You got 13 cards of heart, right, and you got this is 1 by 52, this is to be subtracted. So, 4 by 52, this becomes 17 by 52 minus 1 by 52. So, this is 16 by 52, which is 4 by 13. Let us look at this example. the employees have selected 5 representatives to represent them to the management, and out of these 5 a spokesperson is to be selected. These are different ages and these are genders. So, you have got male and females. What is the probability that spokesperson will be either female or over 35? So, you have to look at both. You have to find out the probability of a spokesperson who is female or more than 35. So, how many total people over here? 5, right. So, either female, right. So, how many females? 2 females, right, plus over 35. How many people are of over 35? Just see this one and this one, right. Those employees who are over 35. So, this is 2 by 5. Now, what is the probability that the selected person is female as well as more than 35? Only 1, right. So, minus 1 by 5. So, this becomes 3 by 5. Okay. So, this is the answer 3 by 5. Now, let us look at one more question. An inspector of the Alaska pipeline has the task of comparing the reliability of 2 pumping stations. So, there are 2 pumping stations and they may fail in 2 different situations. There are 2 types of failures possible: pump failure and leakage. When either of the failures or both occur, the station must be shut down. The data at hand indicate the following probabilities. So, station 1, probability that there would be pump failure 0.07, 0.10 and both happening together is not possible, right, its probability is 0. Station 2, 0.09, pump failure 0.12, leakage, and both because of pump may fail because of both these reasons is 0.06, right. So, which station has the higher probability of being shut down? So, either this may happen and this may happen or both may happen, right. So, again this PA plus PB minus PAB, is not it. So, for station 1, let us look at station 1, 0.07 plus 0.1 minus 0. So, this becomes 0.17, is not it. Similarly, you can calculate for station 2, just add these 2 and subtract this. So, that this 0.09, 0.12 is 0.21 minus 0.06 is 0.15. So, which station has got the higher probability of shutdown? Station 1. Its probability is 17% compared to 15%. Now, before going on the probabilities under condition of statistical dependence and under statistical independence, let me summarize what we have done in today's session. We have looked at several concepts related to probability. We have seen what is an experiment. Experiment is basically a process which gives us different outcomes. So, if you toss a coin, then it is an experiment and it would result in 2 outcomes. We have seen what is mutually exclusive event, those events which cannot happen simultaneously. We have seen what is collectively exhaustive list. So, collective exhaustive list is a list which gives you all possible outcomes. Apart from this, we have seen different types of probabilities. We have seen classical probability, which is the simplest one amongst all those 3 probabilities which we have seen. In classical probability, which is also known as a priori probability. So, you can find out answer to a question without doing any experiment or without using your own knowledge. So, you have got formula available with you, you just put your values in that formula and you will get the answer. That is why it is also called a priori probability. The second type of probability which we have seen is relative frequency approach. Now, this type of probability is useful when we perform experiments and when the questions are such that for which you cannot put them into any formula. So, either you will have past information. So, on the basis of past information you can know what will happen in future. So, we have seen couple of examples. One of the examples I gave was what is the probability that the speaker of TV would blow off due to high volume. Now, to know the answer you need to actually turn on TV to its full volume, is not it. So, you need to perform experiments and when you increase the number of experiments you will get better answer, the answer close to the real one. The third probability which we have seen and which is being used widely by several people is subjective probability. In subjective probability, people make decisions on the basis of their experience, on the basis of their intuition, on the basis of their knowledge of that particular industry or that particular area in which they have been working in. And this is a type of probability which is being used most widely. We have worked out couple of examples related to all those three, and I hope that you would have understood the basics of probability and different types of probability. With this, let me complete today's session. We will have the probability under statistical dependence and statistical independence in next few classes. Let me just tell you what we would be discussing in next few classes. So, you can have statistical dependence probability, wherein the probability of occurrence of an event depends on the probability of occurrence of previous event. You may have a situation where the probabilities are statistically independent. So, the probability of happening an event will not depend on the probability of event which has already happened, and under both these categories we will have marginal probability, joint probability and conditional probability. So, these three probabilities under statistical dependence and statistical independence. We will see all these in next couple of lectures. Thank you very much.